Hi, my name is Azubike, and that is definitely not an American name. I'm from Nigeria, and I lead design computation at Inform Studio. Um, like Leland said, the whole point of this group is to kind of help us grow the knowledge behind computation thinking, not just in one firm or two firms, but across the whole Detroit area and even Michigan at large. Like, how can we elevate the discourse on computational design and just how technology is being used in the workplace? And so I thought it right to present the project that launched Inform Studio into the whole computational space. Um, the Providence Bridge is it about a 300 meter or feet? Feet? Yeah, 300 feet. Sorry, I'm from Nigeria, I get it mixed sometimes. It's a 300 feet pedestrian bridge that sits real nicely in the city of Providence. Sorry, sits real nice in city of Providence, and this was a competition we won in 2010. This was way before I started working at Inform Studio. And the whole point of this project was to convert an existing vehicular bridge to a pedestrian bridge. Actually, more like relocating that bridge because it created such a divide between different portions of the city. And so they needed some type of connector to facilitate like growth between different zones in the city. And from what you see here, what we proposed was more than just a connector. It's something that integrates properly because you have this as a pointer, I guess not, but you have like the knowledge area here, which is where you have actually up top you have RISD. I don't know if you know Rhode Island School of Design, and you also have Brown University, and then there's a knowledge district. So the whole point, and that's downtown, closer to the west. So the whole point is how do you link these two areas together in a way that you can achieve like a cohesive and a well-developed connector between these areas. And so this project, like go back, this project was meant to have like a restaurant or cafe type happening on the bridge. So it's not just people walking over, but people can stay there and actually experience, like create an experience for people, not just going from one end to the other end. This is a view of the what we proposed, cafe, looking out. The point of the presentation today is how did we achieve this for a project that was proposed 2010. The challenge though is if you look in that highlighted area, it looks very clean and like we're trying to achieve this boat-like double curved wood facade. But the reality is this is the Photoshop before it was post-processed. And you can see that the textures here, no one's going to build this. Like this doesn't look like something you can build. This is just Photoshop. And then when you take a look at the base file that was used to generate it, it's just not something you can work with. Now it kind of looks like I'm like calling my firm out, like guys, we just put things together. No, see, but the whole point is vision precedes computation. You have to start. They could have gotten to this point and been like, we can't do this. Let's redesign. They stop with the vision, presented, won the project, and the question is, how do we now build this? That's how you start with the problem. Now you're trying to solve something. And that's the whole idea behind computation. So how did we go from this to this? So yeah, that's that scheme, but how did we get from there to this is the question that we would like to answer today, because that's, again, going back to that whole vision precedes computation thing, if you don't have a problem to solve, then you don't even know the right tool to use to solve it. That initial model was done in 3ds Max, and you cannot do any type of construction drawing whatsoever with 3ds Max. That said, all we had were the plans and some sections, kind of to illustrate the idea behind how we see this thing working. And so, can anybody guess what our solution was at this point? Jump to Revit, right? No. Revit can't handle the double. Revit can, but at the time we were doing it, Revit was not the best tool, because I actually started developing this in Revit, and then I got to a point I'm like, no, this doesn't make sense. So I reached out to my bosses, hey, can we get Rhino? And it was easier than I thought. We got Rhino, I think, that same day. And yes, so now this has a double curve. You know, it's doing what we tried to get it to do. But as we started going through the project, you can see the different phases of the project. At 10% development, at 30%, starts to get more refined. But at 10%, things just went crazy. Dealing with repetitive process, because then we had to put the engineer's drawing and some beams are sticking out, and I have to remodel this like manually to get it to look right. It's driving me nuts. Design changes. Mike's here, he's smiling. Hey Zoo, can you change this? Oh my goodness. Change it. Things go crazy. And then the form itself just wasn't practical to build. Like everything is just different. It isn't rationalized in a way that the people who are going to build this thing, they're probably going to look at this and just laugh, like, are you a joker or something? The other part, which I didn't highlight, is managing origin points in Rhino. It's not a big deal, but the beautiful part about this is it got me to go to New York. And I was able to resolve it. But the interesting thing is, as I was thinking about this, computation seems to always send people to New York. For the people who use these tools, either you're going for a conference or you have a project, I think we should make it a goal for computation to actually come to Detroit. How about people come to think about computation and they think about Detroit? That should become a personal goal for everyone here. And so out of frustration, my co-author figured, all right, Zub, what you doing? And I kind of talk about my projects, and Renee tells me about Pierre, who is here. And I'm like, hey, Pierre, I'm finding this thing difficult. And Pierre goes, wow, you've already started doing it the wrong way. Oh, great, how helpful. But he pointed me, gave me pointers, like sent me to the Grasshopper forum, the community. And why I posted this here is because computation requires a community. Like, you can't do everything yourself. You're gonna have questions, and you need people around who understand these things to kind of point you through how to go along. And also, I'm not going to take credit, but you need to be curious. Like, I could have also been like how I said Inform Studio had vision to keep pursuing it. I could have been like, well, yes, we can do this after all. And then I don't know what will happen next. But I was curious to find out, wait, but people do these things. How do they do them? And that's the thing, curiosity drives computation. Something that's very important. And you can't teach curiosity. You just have to want to know. So at this point, things were going great. Grasshopper was working fine. We got to this level of development. As you can see, initially, along this line, this is just an extrude along a curve. But as you start to see here, it gets complex. It's not uniform anymore. It starts to taper and become a flat panel. there's no way I could have done that in Rhino, but then when again the engineer brings that structural file, things are just gonna go crazy. So like how did we tackle this in Grasshopper? First off, we decided to what are the profiles that are and by profiles I mean like the section of each panel, like how are they positioned in this project. So we outlined 5 different panels. We knew we have 5 different panel types happening at 5 different locations in the bridge. And what we did was then start to create a relationship between, say, the curves or points, essentially, different points on different curves, and we started to manipulate that relationship. This is essentially different lines. We could divide, our input here were 2 lines. The top line, which defines the edge of the bridge, and the bottom line that defines where that bridge at this point. So the point here and the point here, we created a relationship that resulted in a curve. And that means we can adjust everything in between. And that way, when the engineer decides to move their structure out, well, we can easily adjust to accommodate that without me having to repeat that process again. And that's like Leland showed, that was the script. And I don't put it here to scare anyone. This is just our reality. Like we have to deal with what we're up against. And so the next thing, which was the more complex part of it, was the dimple. And you can see that essentially it was just 3 curves that we had and that we used to generate that curvature of the bridge. So you can see at this point we were able to get the surface from an array of different lines, and then with that we were able to get the actual surface that we needed. Again, this is something that comes with Rhino, where you can, instead of people seeing all the scripts, I can have them just view like the sliders that they need to adjust. No one needs to know about what's happening back end. And so we're able to toggle in real time, hey, this form needs to do this or needs to be away from the beam by XYZ amount, and we can pull the toggle for that to happen. And so essentially we did that, we split the panels, and this was our deliverable. No drawings. The reality is we had drawings, but they were almost useless because this was going straight to the machine. And that raises a lot of questions. Computation leverages data, not drawings. So we're used to the whole idea of, oh, I need my construction drawing. No. Your drawing contains information, and that is what computation needs. Your information might be a line, it might be a point, it might be numbers, it might be text, but the whole idea is, what am I doing with this information? And that's the beauty of Revit. Revit isn't for construction drawing, it's a database. So how do I take all that information, leverage it to make sense for me? And so what we sent to them, this was a short drawing. Can you imagine? Like they sent this, what am I meant to do with this really? Like this just tells me doesn't really give me detail. And they know it, they know they're going straight to the machine. So, well, to fulfill all kind of righteousness, they just sent this, I don't know. But the whole point is, this was the workflow. We went from our panels that we gave them, they rationalized it in a way that it accounts for their machine tolerances and the tolerance of the material. And then they actually split the boards and then created every fastening point. And then tagged every board and then unrolled every board so that, because it's 2D, it needs to be flat so the machine can cut it. Can you imagine if they did this manually? No, they had grasshopper scripts in the back running this process. So if we even made any change on the design end, it's going to update and it's going to have a grid number, and all that process is streamlined. I guess the next thing is, so as we start to think about this, that means we're going straight from design to machine. That's pretty awesome. And that needs to make us, again, be intentional with that information. It raises a lot of questions. Who's liable for what? Who's in control of what? But yeah, let's start it and let's have this conversation, not shy away from the conversation. So yeah, we started with that 3ds Max file, and this was the model that situ construction in New York. The guys responsible for the fabrication. This is what they sent us. At this point, I can sit on my chair and know that yeah, this stuff is going to be built, and rest assured, it is going to be built. So these are all the wood stock, because they're standardized sizes, and that's one of a couple of the panels the same type. And this is the water jet cutter cutting out some of the steel substructure. And you can see the assembly at this point. It looks like what we modeled, and that's the bridge today. Well, this is maybe 3 weeks old, and the awesome thing is we get updates on this bridge every week by a resident who's eager to see this project come alive, which is just awesome. Every week we know where this project is at, and to see that you can create something that people relate with is pretty phenomenal. And so the next thing, just like Leland said, is computation has a past. Like this project was 2010. We started in 2013, 2014. We did some computation in 2014. It's happening now. Again, this was the project that launched us into computation. What we're doing now is some pretty sick stuff. And are we ready for the future? That's the question. Because now, if we have all of this data, all of this information kind of just hitting us, our Revit models hosting tons and tons of information, and then you see that kind of job description from WeWork, who have hired the people who developed the tools that Leland was showing us. What does our industry look like, and are we ready for it? It's one thing for us to act like it's not happening, and it's one thing for this situation to tell you I'm here. You have to deal with it. So, just a call to action. Are we ready for it? That's it.